All right. So today I'm going to be talking about interactive computing on Expanse and the different modalities for that. So let me go ahead and fire this up. Okay, so in this talk, I'm going to address interactive computing, which is where you actually get onto a compute node and you're able to run mock codes interactively and interact with them on the computer. This is a Expanse. You've seen this architecture a lot. We have 728 compute nodes, and we're getting more. And we have a lot of innovative operations on Expanse. And this one today, in my talk, I'll focus on interactive computing, what that means, the different things you can do with it, and what are the advantages of interactive computing. Primarily, you get to work on that compute node in a secure, safe way. We're highlighting security today so that you guys have a feeling for how important this is, and how to make sure you're running jobs securely and in a way that helps the Expanse system itself run better. So there are several aspects. So again, interactive computing refers to software that accepts input from the user. Right now, I'm moving a pointer. You are running an application called Zoom. A lot of applications running on your local laptop, those are interactive from a computer science design perspective. Software that accepts input is an interactive piece of software. On HPC systems, it's an evolving concept that a few years ago didn't even exist. But interactive computing means you are on that compute node and you have secure access to it. Ideally, on that compute node, you would be running with no other jobs, user jobs running, unless you chose to do it in the shared mode. But even then, we make sure that the part of the partition that you're running in is secure and allocated only to you. Your data is secure. We do a lot to make sure things are secure and safe, that the system runs appropriately. So when you're on that node, you can do whatever you need to do. Maybe you have a code that takes a long time to compile and it'd be faster on a compute node. You could have code applications that have a lot of data sets that are large, and you need to bring them onto that compute node, and you want to do it manually. You might use a visualization tool like ParaView or VisIT. We have a talk on that this week, where you want to view your data because it's too large to get onto your laptop. And we want you to have some fun running things like Jupyter Notebooks, MATLAB RStudio, and we have different ways for you to get that access. So here's a scenario of the interactive computing where the user is coming in and interacting right now. If you log on and SSH on, then you're accessing one of the login nodes. And what happens is Slurm then goes and finds your job, and through some kind of secure, like we have to have a VNC connection, some secure SSH type connection allows you to be on that node. And you can get that node allocated and type who am I. You're the same person, and type who to see who's on the machine. And instead of 600 or 1,000 people like on the login node, it's just you. It's pretty nice. You have control, but that means you have the ability to run and interact with your parallel model or some X11 based application. Interactive computing applications that are commonly used include notebooks, very popular, and ParaView, and MATLAB or RStudio. All right, so how to get a compute node. We've talked about this before. I tested these commands on the 27th, so they work very well. I used them last night. So you use the slurm srun command, and again, you define all of the attributes that you need to make this get the right partition, that you have the right account. And then what happens is you submit this to the slurm batch scheduler and wait until you get your allocated resource. It can take a moment, it can take a few minutes. On a very busy day, it might take even longer, depending on the partition that you're trying to get onto. But once you do, then you have access to your interactive node. So in this example, I ran the srun command, looking for the debug partition. I require nodes, one node, and 64 tasks per node. 128 gigabytes and I want it for 30 minutes. And on here, I just run a simple OpenMP command. And again, on that interactive node, you'll get even your serial code will run better if you're timing it. Here's a more detailed example of this srun command. And then I submit it, I get back that job number, queued and waiting. And then once it's allocated, I know I'm on another node because my node ID, the node name has changed. And in this example, I asked for a GPU. And to verify you're actually on it, you can run the NVIDIA SMI command and you'll get back this information. You won't get this information if you're on a GPU. And so sometimes if you're doing a lot of work and very, very busy, you might run the wrong srun command. So make sure you're on the node that you want to be on. And when you're done, make sure you exit it so that you don't get charged any more than necessary for your work. And so what are ways we're going to interact with data, for example, on these HPC nodes? Just looking in the file content, sometimes your files are too big, you can't even download them onto your laptop, and you don't want to mess with file staging. You can go right onto the node and look at very large files. That's interactive computing in the sense of interacting with data. You could be plotting some data. I'll show you an example of using GNU plot. And we also are very emphatic about the fact that we don't want you running any visualization or X11 based applications on the login node. That's not appropriate. Those resources can't support 6,000 people coming on and trying to run MATLAB, for example. But you could also, but we support running MATLAB and R and notebooks on the interactive nodes, on the compute nodes. And you can also run a data viewing application. There's a NetCDF has NCView, which allows you to visualize your data. So you don't even have to move your data around. And so we're trying to improve the performance of how fast you can get your work done. X11 forwarding, most of these really GUI apps require some kind of X11 forwarding so that the visual GUI environment that I'm seeing on my laptop can be communicated between my laptop, my local resource, and the remote one. And that's a lot of information that has to be transmitted between the two pieces of equipment. And so for me, I had to install X11 forwarding software, Xquartz, and use a commit connection that you pass an argument, this -y, and that tells the SSH daemon when it connects you that you'll be doing forwarding messages associated with the GUI environment. And for Windows, I don't have that set up. I don't have a slide on that, but I will add it as I get somebody with a Windows laptop to show me an example. So GNU plot's been around forever, and it's very simple, but it can be used to plot very complex data. We have that on Expanse. It's designed for generating, it's really useful for generating plots inside your application. So you can include calls inside your Fortran or C code and have a series of images generated. There's other libraries you could use, but GNU plot's been around, and so I just wanted to show you that it still exists and you can use it. And this example is I just went into GNU plot and I typed plot sign of X, and this this plot came up. And I can also save it to a file on Expanse as well. So whatever you're doing, if you need to visualize, you can just do something as simple as GNU plot. And this is just an example of another model I ran with GNU scripting and generated that. So there's lots of examples out there, but you can use GNU plot. You can run MATLAB from the command line. The MATLAB environment in the command line runs. And I don't have my Expanse working, but I can show you on the Triton Shared Computing Cluster. That's a campus condo cluster. You can grab an interactive node, and then after you've got that interactive node, you can run MATLAB doing the GUI, without the GUI, just from the command line, And you can also launch MATLAB with the GUI. You have to set the X11 forwarding. You have to make sure you've got the right login here, and then request that interactive node and then launch MATLAB. And in this sense, you will get the MATLAB interactive environment. So we do have that capability on Expanse. We require that you have a VNC for it to work. But to be honest, my example last night was not working. So I'll show you in a moment how to run these applications through the Expanse portal. And if it's supported in the portal, it's really the big advantage is that you never have to worry about the software environment. Expanse takes care of all of that. The portal takes care of all of that. So for things like MATLAB and R and Jupyter Notebooks, adopting the habit of launching them through the portal means you are always going to have the most supported software stack, and it will work for you. So that's a key feature of using that portal. You can run R code as well. So you can also view NetCDF files or other high-end file storage systems like HDF. They have visualization software. You can do just a dump. This is a NetCDF dump, and NetCDF is an object-oriented data storage system, high speed, and it's used by, I used it for climate, for an ocean modeling system. So if you have your data in NetCDF format, you can run your model, get on an interactive node, and check out your data and investigate the data in either just from a command line dump. Again, you're interacting with your data, or running something with a visual GUI component to it. And in that case, we really want you on that interactive node to visualize it. Okay, so the next thing to talk about is the Expanse portal. So like I mentioned, there's a lot of applications that are supported. We try to support the big ones that have, and the ones that have been ported to the portal framework, which is based on Open on Demand. The key ones are R, MATLAB, and Jupyter Notebooks. So here's an example of the portal. You can do file management either through the portal interface or launch a terminal. Launch a terminal and look at your data files and manipulate files. You can launch a terminal shell, and if you add a file here, it will show up over here, and vice versa. So it's a completely transparent access to your files on Expanse. So you can also run MATLAB. You go find the MATLAB application. I wanted to point this out. In order to use MATLAB in RStudio, you need to have a VNC connection. And so make sure you've got something secure like that. That guarantees that security. So you should have that running. And if you have a problem, contact the support people. And then this is just a form for building a compute job. I submitted, it shows up here. I'm going to run MATLAB. And then eventually my MATLAB job will be running. I click on the link and the MATLAB environment will pop up. Same thing for notebooks. We support Jupyter Notebooks. At the back end, it uses our Galileo client. The key advantage here is Jupyter Notebooks don't launch securely by default. And so we're trying to make sure people, when they run notebooks, we do have that HTTPS connection. I'll talk about that in a lot more detail in a moment to reinforce what Nicole was saying. When you get that URL from your Jupyter Notebook command, either launching it through Expanse or launching it on the command line on Expanse, you get a URL, and it needs to be HTTPS, because effectively this whole wonky looking URL, that's a password. That's a direct connection to your file contents on the system. And without HTTPS, that password can be hacked over the internet, and people will try. We get hackers attacking our systems all day long, and staff that are dedicated to protecting the system. So make sure you're doing whatever you can to launch things securely. we try to keep all the accounts isolated and sandboxed on Expanse. So if this URL got hacked because you walked away from the browser during to go get a cup of coffee and you're at Starbucks, if that got hacked, the most impact would be on your Expanse accounts, but you don't want to lose all that data or have somebody come in, because we do try to sandbox all of the accounts, but there's clever people out there that are capable of hacking their way in. So be careful with that. It's a privilege that it gets supported, and it's a reason that we're here, is to help you guys get your work done, but we need help back from you to make sure that you run things security. So let's delve into Jupyter Notebook security a little bit more. So like I said, by default, when you launch a Jupyter Notebook, it's not secure. It's very popular, but it's not secure by default. So we want to talk about how to get that. I'm sure all of you now have seen and heard of Jupyter Notebooks. They're used in high school classes all the way through, professional work. And in science, they're very, very popular. You can install a service on your laptop called Anaconda, and Anaconda gives you access to a lot of features and applications, in particular Jupyter Lab and Jupyter Notebook. And notebooks are great because you're in there interacting with your system. But these interactive services like the Jupyter Notebook, they have a key vulnerability. They provide access to the HPC file system, often over HTTP. And that's bad because that is not encrypted, and anything you put over the messaging that you're sending between your Jupyter Notebook, which is a web-based app, and the remote resource where you're trying to work, it's vulnerable. If you're just doing it on your laptop with Anaconda and you're not going out into the web, well then it's safe, and your data, your application, and your system are secure. But in the model where you're accessing a remote system, you want it to have a secure access. You want it to be encrypted. So we don't allow things like this to run directly. So we try to enforce security. And so, use secure connections, and there's many ways to connect securely. The Expanse portal is our preferred system that you use, but you could do SSH tunneling. First of all, you run it from Anaconda on your laptop, and if you're staying on your laptop, you're secure. But you can also connect over HTTP with SSH tunneling, more secure, over HTTPS using our service. And the Expanse portal actually uses that satellite reverse proxy service. I'll talk about that in a moment. And so you can launch Jupyter services on CPU and GPU using interactive nodes, and then you can run things from the command line, and a Slurm batch script. These are the different ways you can use Jupyter. Remember, treat that notebook URL like a password, because it is a direct access. So these are some slides from a presentation that Marty gave last year, and I've got the link to it because this is a great detailed overview about running Jupyter Notebooks that we present somewhat annually. Anyway, here's the architecture. You're on your laptop, and you want to get or a workstation, and through the internet, that cloudy thing, you want to connect to Expanse. And so you have these login nodes, you have this internal network, and then there's some file systems, and then there's those 700 plus compute nodes and these management nodes. And when you do connect through other applications, you'll be able to get into this internal network. So to do it, you want to install Anaconda and run Jupyter Lab locally. Notice the URL when you launch Jupyter Lab will be localhost. So you're running it. So far, you're in your laptop ecosystem. You've not gone out to the internet, so it's assumed that your laptop is locked down and secure, and so it's safe to run your notebooks there. If you're running Anaconda on the laptop, you launch it, and you can pick either Jupyter Lab or Jupyter Notebook. Jupyter Notebook will just launch one notebook at a time, and you can navigate through your files and launch a notebook. Jupyter Lab gives you a few more features like you can do file browsing and launch multiple notebooks, but also you can launch a terminal shell. It has other features. So that's Anaconda. All right, so moving along, you can also send messages between your laptop and a remote resource where maybe Jupyter Lab is running. And so Jupyter Lab, when it gets launched on the remote resource, you want to make sure that you have some kind of connection. So one way we do that is with tunneling. So I want you to realize, though, the reason for this diagram is you're on your laptop, you used SSH to go over to a remote resource, you launched a Jupyter notebook, you got a URL back, but it's over HTTP. And actually what happens when you get that URL, it's a completely different connection stream. It's not on this SSH, which is secure and encrypted. So this is unencrypted HTTP over the internet. It's this connection here that could be hacked. So we need to find ways to prevent that. And one way you do it is with something called SSH tunneling. SSH tunneling allows you to set up, you have your first SSH connection, which is what you see when you're typing on the terminal. The second SSH connection, which is tunneled, is secure. So now you're using 2 ports on your laptop. And the first one is this SSH connection, and the other one is an SSH connection to that Jupyter notebook port, the port where the notebook is hosted. And it's HTTP, but it's inside a secure and encrypted connection. And you can use this, and we have examples in we have a repository that shows you how to, that on security. And so SSH tunneling has been around for a long time. What we have found with SSH tunneling, especially on HPC systems, they're not that stable. You might ask for a port. You have to define the port that you want. So here you're defining a port on my local host, talking to a port on my local host, and it's pretty much guaranteed that you'll get those 2 ports. But on a supercomputer, you might ask for a port and it's already taken. And so you might have trouble figuring out the port that's available. And then we find that they're just not stable. They time out, they get interrupted. And so you can do it, you can choose to use SSH tunneling, but it's just not as stable, which is why we worked on the satellite project and the Galileo client that you've probably heard about already. So again, you can have a simple secure connection, and please use it, but just make sure you use that, realizing that in this case, it is encrypted. So in the next figure, we start talking about, okay, how do we get connected to the HPC system? And again, I'm showing that you can use SSH tunneling. And the way you do it is you first log on through your terminal window and SSH onto the login node. And then you get your interactive node and you get a port and you set up an SSH connection that's encrypted through the tunneling. But again, you have to get that interactive node. You have to know what port number you're going to be able to use on that remote port, and then you're depending on that connection to be secure. But we don't want you using anything that's HTTP. So we don't want you just launching Jupyter from the command line. First of all, it's not secure, but also it's a resource that's not intended, the login node is not intended to be used for Jupyter notebooks. So how do we make it secure? You can go on to SSH, you're on the internal network. So because you're on the internal network and you got there through a username and password that we trust, then we know that you're part of the system. And so internally on Expanse, what we've got is a service called the Satellite Reverse Proxy Service. And its job then is to uh, work with jobs that get launched on a compute node and set up a proxy so that all of the messages that are exchanged between your notebook that's running on a compute node and your laptop browser are going to pass through the satellite reverse proxy service, and they will be over HTTPS. So it's a sort of a replacement for SSH tunneling. So again, you come onto the login node, you submit a job to the batch scheduler is what actually happens, and a job gets launched on the compute node. The Jupyter Notebook gets launched on the node. It is HTTP, but it's still inside the Expanse internal network. But it gets runs through the satellite reverse proxy service, which is then going to communicate back to you over HTTPS. And you'll know you've got that working when you see this HTTPS. It's still a wonky looking URL associated with notebooks, but it's secure. And that's the model we're recommending so that you're not over HTTP connections working on Expanse. So it's a prototype system that we've been developing for a couple of years, and it does allow you to have secure Jupyter Notebook connections. They're hosted internally, and then you get access to that service outside of the cluster firewall. And it can be run on any HPC system capable of supporting Apache. So Galileo is the client that we recommend you use. It's our second generation version, and Marty has worked on it, and he does a great job of keeping it updated and adding any changes and updating and maintaining it. And the key features are you don't need to install the Conda environment, although we'll teach you how to do that working with notebooks. Peter Rose will be doing a talk at the end of the week. It may be that you have to be so custom that you're going to install Conda and work on your notebooks locally in your own directory, and that's fine. I'll get into more features in a moment. So you're going to call Galileo from the command line. And if you want to know the different attributes that you can set, those are going to be printed out for you. You can number of nodes, the partition, the reservation, your account, things you would expect to see there. Even if you have your own custom environment modules or Conda environment, you can pass that to Galileo. And then it will create a script for you. It will build a script and save that script for you in your home directory so you can see what it looked like. And it will send a request to satellite to get a token, which will be incorporated into that secure URL. Satellite then passes that token to the batch job, and then Slurm takes over with all the information it needs to launch a job for you on that remote compute node. And when that node gets allocated, then the script will launch a Jupyter Notebook request and generate that secure URL that you get that URL back when you first launch the script. And then you sit there and you'll wait until the node gets allocated and the job is up and running. And so there's the steps for doing this from the command line are log in and get the right environment. Make sure you've got this path set up. Your training accounts will have this path set up by default. And then make sure you can run Galileo. Launch your Galileo request. Notice you can do this on the login node. The advantage of using Galileo is that from the login node, you can submit a batch job to the queuing system that will bring you back a working notebook on a compute node, and then you can set about doing your work. When you run the Galileo command, you'll get a whole bunch of information printed back, which I've snipped out for tightness on just the presentation. But you'll be told submitted Jupyter launch script to Slurm, and you get a job ID. At that point, you know that the batch script was built properly. A batch job is a batch job is a batch job. So that script worked. You have a job ID, and also you'll get back that Jupyter Notebook URL, which is a secure HTTPS. What you do is copy and paste that URL into your web browser window. And again, it's a secure one. So now this is your password to your system. And so then you then launch your browser, put that in the browser, and you have to wait while you're waiting and waiting for the job to be allocated a resource and then launched. At some point, and I'm monitoring this separately, you'll see, oh, it's running, and then things will start happening for you. What we do is when you go to that URL, you'll get a pending page from the satellite server. And if it's in the queue and waiting, this little green dot bullet will light up, and as it moves through the different stages of being allocated the resource, it begins to run. It still then takes time for it to get mapped through the whole system, and that could take a minute or two, and then eventually it will get fully proxied, and at that point you'll have your notebook will show up. And remember, treat the notebook like a password. Can't say this enough for you guys. This is a very important idea. And so here we're going through the stages of the pending page. Eventually, all of the state bullets are lit, and up comes your notebook. And at this point in time, you're directly connected through a whole lot of hardware, layers, nodes, um, port forwardings to your Jupyter Notebook or a Jupyter Lab, and you can start doing the work on the remote system, and everything you do will be running on an Expanse node. And at that point, if you're visualizing data, the same, you'll have access to everything as if you were just sitting there on the terminal shell. Same thing for Jupyter Notebooks. You just want to make sure that you request the GPU. It works exactly the same. And how can you tell you're on a GPU is you run the NVIDIA SMI command and you go, oh yes, okay, my notebook is running on the GPU. And again, if you're doing a lot of developing, coding, debugging, testing, scaling, you might be trying to run multiple, grabbing multiple nodes for multiple experiments. And just always make sure you use the right commands. I tend to save the commands that work into little text files, kind of little help me files, and that way you don't lose them. So to wrap it up in our repository, we have quite a few examples, parallel and serial. And later on this week, you'll go to a couple of talks with Mai Wynn and Paul Rodriguez, where they're showing you how to run machine learning based notebooks in parallel on the HPC systems. And so you'll have access to all your software, but we have basic examples that work, that we try to keep updated. And so when you're just starting out, it's good to have like just Hello World. And I always tell my students the advantage of Hello World is if it works, it should always work. If it worked once for you, if given you haven't made a change to Hello World, it should always work. So when you're heavily into testing, debugging, and developing your model or your notebook or whatever application you've got, and all of a sudden things aren't working, if you try Hello World, that's what sort of raises the bar to what part of the system is working for you. The system's working, you can log on, notebooks run normally, then you can go, okay, there's something wrong with the new changes I made in my application. Because sometimes the layers and the stacks, it's obviously a complex environment. And so knowing that certain things work, Hello World works, or basically a unit testing version of your software that should always work. Try to always have that so that when things go wrong, you can run that and know whether it's Expanse could be having a problem with some aspect of the software layer you're working with. Okay, so there's a few resources in conclusion, and then feel free to get in touch with us when things go wrong. And that's the end of my talk. Are there any questions?